Welcome to my YouTube channel. Today, we're exploring Structures or Why Things Don't Fall Down by J.E. Gordon, a book that makes the science behind why things stand up or fall down surprisingly fun and easy to understand. Whether you're curious about bridges, buildings, or even bones, this book breaks it all down. Gordon starts by showing us that structures are everywhere, from the tallest skyscrapers to the smallest plants. He explains basic concepts like tension, compression, bending in shear, forces that every structure must handle. Imagine a bridge. Its cables are in tension, the pillars are in compression, and everything has to balance for the bridge to stay up. Even our bones work this way. They're strong in some directions, weaker in others. The book dives into the history of engineering, showing how ancient builders learned from both success and failure. We hear about famous disasters like bridges collapsing or ships breaking apart, and how these failures taught engineers to build safer structures. Gordon introduces ideas like stress and strain. Stress is the force inside a material. Strain is how much it stretches or squashes. He explains elasticity, how things bounce back, and plasticity, how things bend and stay bent, using simple examples like rubber bands and putty. One of the coolest parts is how Gordon connects engineering to nature. He compares bones to steel beams, tendons to ropes, and even talks about how plants and animals have evolved their own engineering tricks for survival. For example, an eggshell is strong because of its shape, but fragile if you press in the wrong spot. Trees and bones are built to handle wind or weight, but can snap if pushed the wrong way. Gordon also explores why things break. He talks about cracks, how a tiny flaw can grow and cause a disaster if not managed. Engineers learn to spot these weak points and design around them. He explains how materials like steel and concrete behave differently. Steel is great in tension, concrete is strong in compression, but both can fail if not used right. Now, let's talk about good gardens. Not just the literal ones, but the idea of tending and caring for structures like a gardener cares for plants. Gordon suggests that engineers are like gardeners. They watch for signs of trouble, nurture their creations, and learn from nature's designs. A good gardener doesn't just plant